2015 Senior External Exam Physics, Paper 2, Part A, Question 3. A car can just maintain a speed of 64.8 km per hour as it drives up a steady incline of 10 degrees. Find the car engine's power rating if the mass of the car is 1.3 tonne. Right, we need to find the power rating of the car, and power is given by work over time. Power is measured in watt, and the units of it are joule per second. Work is measured in joule, time is measured in seconds. We also know that work is force multiplied by distance. Divide that by time for power, and distance over time is velocity, so force by velocity. So what we're after here, if we're after the power of the car, we're after the force of the engine of the car multiplied by the velocity of the car. Now, our velocity is given to us as 64.8 kilometres per hour. We need to change that into SI units of metres per second. So therefore, the velocity of 64.8 kilometres per hour, to change that into metres, we multiply by 1,000, so it's 64,800 metres. And if it's per hour, we divide by 60 to get it into minutes, and then we divide by 60 to get it into seconds. So when you multiply all of that out, you get the velocity of the car up the 10-degree plane is 18 metres per second. Now we need to look at the situation of the car, and we need to be able to calculate what the force of the engine of the car is. To be able to do that, we need to work out what forces are acting. We have the reaction force of the road. We have the force of the engine. The force of the engine is up the plane, and we have the weight force, which we'll call W, acting vertically downwards, but that is at an angle of 10 degrees here to the perpendicular to the plane. Now, we know that the car is travelling with a constant velocity, so if its velocity is constant, we know that the acceleration of the car must be zero, and therefore from Newton's second law, if the acceleration of the car is zero, the sum of the forces must be zero. So therefore we look back at our diagram and we need to sum the forces. Vertically we have the reaction force upwards, and downwards we have the component of the weight force, which is at perpendicular to the plane, and so that would be W cos theta. Now up and down the plane we have the force of the engine up the plane, and we have the component of the weight that's acting down the plane, which is W sine theta. So the force of the engine is equal to W sine theta. Now they're equal and opposite, but when we add them together it's zero. So therefore, to work out the power of the car, it's the force of the engine multiplied by the velocity of the car. So we're talking about W sine theta being the force of the engine multiplied by the velocity of the engine. So it's mg sine theta times velocity. So therefore the mass of the car is 1300. The acceleration due to gravity is 9.8. The angle is 10 degrees, so it's sine 10 degrees, and the velocity of the car is 18 meters per second. So when we multiply all that out, we get $39,800. Sorry, not dollars. $39,800. The unit is watt, but we're actually asked to calculate it in kilowatt, so therefore it's 39.8 kilowatt.